during the waiting queue, each device manages, okay, their own queue, okay, waiting. So each device has the, if you read the data from the screen, how the alert, 1,000, you need to take care one by one. So at the time, each device manages their own queue using PCB. Then it's a queue. How can you implement a queue? There are different ways. In your data structure class, one of the ways is using linked list. Using the linked list, you can implement. This is a linked list. Using the linked list structure, you can implement such a queue data structure. Okay. And we already talked about these issues in the mobile system. So nowadays, that's pretty much enough. Okay. So this slide is explain again. There are two steps when you create a new process. Who create the process? Current process. Create the child process always. Okay. So that this is the for what? This is a fork copy. But nowadays, do we need to really copy this part code? We can share, which is called a copy on write. It has actually the address. But in case this data is changing, then at that time write. Okay? So that's called a copy on write to reduce the time for better performance. So this is a fork. After fork, it will be separate. But their parent process will be this one. Okay? This is a process tree. You can see Windows use the same thing, process tree. Okay? And wait is the parent process while the child process is running. They are waiting for the termination, exit of the process. Then resume their job. Okay? If you do not have the wait, that means there's no parent is waiting, then at the time it can be open process. So let's try to understand this code. This is the C program to create a process. So if you do not know the C, it's okay. It's a very intuitively you can understand. It's a simple code. So we can start. It's a main. Always starting your job process from the main class, main function. It's a main function. And the PID, we have the PI process ID. First, fork means this is a current process. Current process. Fork, which means process 2. Child process will be created. Okay. Then you need to check the process ID. If process ID is less than 0, that is the error. Okay. In case you do not have enough space on the memory, it will be error. Then terminate or the return 1 and done. Otherwise, if PID equal to 0, okay. If PID equal to 0, this is the child. That means because this time, this one is copied to here. It's exactly same code is running. At the same process count, the process count is the same. So this at this time is concurrently running. Okay? Concurrently running. So that means if PID is 0, that means it's a child process. Why PID is 0? Child process should have the PID. Then child process is PID equal to 0. This PID, it has the exactly same copy here. This process has PID in the PCB, not in this code. In this code, the PID, there is no PID. Is there any other child process here? That doesn't make sense. So PID will be 0 in this child process. That means it's a child process. Okay? That doesn't mean this child process ID is 0. No, it has a child process ID like the 10. Okay, but that is not in this code. It's in the PCB. In this code, the process 1, because it has a child, right? So PID of in this code, parent process is a child process ID. Okay? So you can differentiate. Otherwise, no way to differentiate. It's very hard to which one is the parent, which one is the child. Because concurrently, this code will be running together. So in case PID 0, there's no child process of the child. Okay? PID 0. Then we can load using the exec, the ls command. Then this command will be ls. Then, what about the parent process? Otherwise, which means successfully I create successfully the fork, which means I'm the parent. Okay, parent, we can wait until this one will be done. ls is done. Okay, so you should be able to this code. First time it's still confusing. Why? This one, the child does not have a child, right? So that is the reason it says 0. Okay, to check whether this is a child or not.
Excuse me.
Yes.
Can we say child carries parent's ID?
No. That is in the process, the PCB, parent process ID. It's called the PPID. Will be not in your code. Okay, in the PCB will be managed. Okay, we will see the example. We have a time. Maybe next class. Let me. This is the exactly same thing, but using Windows API, the C and everything. So next class, I will demonstrate some of the comment regarding to the process management. Then we will have the quiz. Then continue for the chapter 4. Thank you.